In our previous discussions, we established the fundamental requirements of a logistics system and explored the concept of packaging hierarchy and its impact on warehouse operations. In this video, we turn our attention to a crucial element that underpins the movement and storage of nearly all goods: load carriers. The title of this module, Load Carriers in Logistics, might seem simple, but the choices we make regarding these carriers and how we manage them have far-reaching consequences for the efficiency, cost-effectiveness, and overall design of any logistics system. Consider this. The vast majority of products do not travel through the complexities of a supply chain as individual loose items. Instead, they rely on some form of load carrier, a platform or container, to facilitate their handling, movement, and storage. Think about the sheer impracticality of manually moving hundreds or thousands of individual bottles, for instance, through a bustling warehouse. The time, labor, and risk of damage would be immense. Load carriers solve this problem by enabling unitization, the grouping of multiple items into a single manageable unit. This seemingly simple act yields significant advantages. It enhances handling efficiency because we can move larger unitized loads instead of individual items, drastically reducing the number of handling steps required, which accelerates throughput and lowers labor expenses. Furthermore, load carriers, particularly pallets and stackable containers, allow for more efficient vertical stacking and organization within storage areas, maximizing the utilization of valuable warehouse space. By encasing and supporting products on or within load carriers, we provide crucial protection against damage during the often rough journey through transportation and storage, which is especially vital for delicate or high-value goods. Moreover, standardized load carriers are a prerequisite for the successful implementation of automated material handling systems. Automated storage and retrieval systems, automated guided vehicles, and robotic picking solutions are all designed to interact seamlessly with consistent unit loads. Finally, when goods are organized on identifiable load carriers, tracking and managing inventory becomes significantly easier and more accurate, as counting and locating units are far more efficient than dealing with scattered individual items. Given the fundamental role of load carriers, it follows that all relevant components of a logistics system must be carefully adapted to the specific types of carriers in use. Let's consider how this adaptation plays out across different aspects of the system. The selection of racking, shelving, or automated storage technologies is intrinsically linked to the dimensions, weight capacity, and handling characteristics of the primary load carrier. For example, the design of narrow aisle racking is dictated by the precise dimensions of the pallets it's intended to hold and the operational capabilities of specialized forklifts. Similarly, the fleet of forklifts, pallet jacks, conveyors, automated guided vehicles, and robots must be compatible with the load carriers they are expected to handle. A forklift engineered for standard Euro pallets will struggle with oversized containers, leading to inefficiencies and potential damage. The design of trucks, trains, and ships incorporates specific loading bays and securing mechanisms that are optimized for common load carrier dimensions, ensuring efficient loading, unloading, and the safe transit of unitized goods. Furthermore, the design of secondary and tertiary packaging must complement the chosen load carriers. Cartons must be stackable and stable on pallets, and the methods used for securing loads, such as strapping or stretch wrapping, must be effective for the specific carrier type. Crucially, information systems like warehouse management systems and transportation management systems need to track inventory and movements at the load carrier level. Detailed information about the type, quantity, and location of units on each pallet or within each container is essential for effective warehouse and transportation management. Finally, the physical design of loading docks, including the specifications of dock levelers and door sizes, must accommodate the dimensions of both the transportation vehicles and the load carriers being transferred. This intricate relationship between load carriers and the entire logistics ecosystem underscores the importance of the guideline presented on the slide. Keep the number of different load carriers as small as possible. This seemingly simple directive holds significant weight in optimizing logistics operations. Why is limiting the diversity of load carriers so beneficial? Let's explore the key advantages. Managing a smaller range of load carrier types inherently simplifies processes across the entire logistics system. It minimizes the need for a wide array of specialized handling equipment, diverse storage solutions, and complex operational procedures. Standardized handling procedures become easier to implement, train on, and optimize when dealing with a limited set of load carrier types. This can translate to faster processing times, reduced errors, and increased throughput. Furthermore, automated systems thrive on consistency. A limited selection of uniform load carriers makes the design and implementation of automated handling and storage solutions far more straightforward and cost-effective. Training warehouse personnel on the correct handling procedures for a smaller number of load carrier types is more efficient, less time-consuming, and reduces the likelihood of errors in operation. Standardized load carriers are often designed for efficient stacking and storage, allowing for better utilization of available warehouse space, both horizontally and vertically. Finally, consistent handling procedures tailored to a limited number of load carrier types minimize the risk of damage that can occur when using inappropriate equipment or incorrect handling techniques. Building upon the idea of minimizing variety, let's now consider the significant advantages of using standardized load carriers. Standardization, particularly at the tertiary level with pallets, and increasingly at the secondary level with specific container sizes, offers a wealth of benefits. Standardization in load carriers brings numerous advantages to logistics operations. Standardized load carriers are engineered for stability and to maintain the integrity of the load. Pallets adhere to specific dimensional and construction standards, ensuring they can be safely stacked and transported without collapsing. Standardized containers often feature interlocking designs that enable stable vertical stacking, significantly reducing the risk of product damage and workplace accidents. Furthermore, standardized load carriers often facilitate easier and more consistent identification. The uniform size and sometimes color coding of certain reusable containers, for example, allow workers and automated systems to quickly and accurately recognize and process them, leading to improved sorting and routing accuracy. The consistent dimensions of standardized load carriers enable the optimal design and utilization of storage shelves and racking systems. When load carriers have predictable footprints and heights, warehouse layouts can be planned with greater precision, minimizing wasted space and maximizing storage density, which is crucial in high-throughput environments. Many standardized reusable containers, often manufactured from plastic, are designed to be easily washable and sanitized. This is a critical advantage in industries with stringent hygiene regulations, such as food and pharmaceuticals, helping to prevent contamination and ensure product safety throughout the supply chain. Standardization often implies a consistent and known tare weight for the empty load carrier. This is essential for accurate weight calculations during shipping, receiving, and inventory management. Knowing the precise weight of the carrier allows for accurate determination of the net weight of the goods being handled. Finally, standardized reusable containers can often efficiently consolidate the contents of multiple non-standardized primary or secondary packages. This consolidation leads to more condensed storage, reducing the overall warehouse footprint required for the same volume of goods and streamlining internal handling processes by allowing pickers to access multiple items from a single standardized unit. The widespread adoption of standards such as the Euro pallet, with its defined dimensions of 1,200 mm by 800 mm, has been a transformative force in European logistics. It has created a common platform for handling and transportation, fostering seamless interoperability between diverse companies and across complex supply networks. To further solidify our understanding, let's examine the various types of load carriers illustrated on the slide. Each of these serves specific purposes within the logistics landscape. Consider first the wooden pallets, which are arguably the most prevalent load carrier globally. Their appeal lies in their relatively low cost, inherent strength, and ease of repair. They primarily function at the tertiary packaging level, unitizing cartons and other packaged goods for efficient transportation and storage. However, they can be susceptible to damage from impacts or moisture. Next, we have plastic pallets, which offer a compelling alternative to wood, providing enhanced durability, washability, and resistance to moisture and pest infestations. They often boast more consistent weight and dimensions, contributing to greater predictability in automated systems. While their initial investment cost is typically higher than wooden pallets, their extended lifespan and reduced maintenance requirements can lead to long-term cost effectiveness, particularly in closed-loop supply networks where pallets are repeatedly cycled. In some countries like Norway, for instance, plastic pallets are most common in food and FMCG warehouses since they are easily washable. Then there's the cardboard box, which is primarily considered secondary packaging. They are lightweight, recyclable, and can be easily customized to fit specific product dimensions. However, they generally lack the stacking strength and durability of pallets or rigid containers needed for high-density bulk storage and repeated handling within a warehouse environment. We also see rigid plastic containers or totes available in a wide array of sizes and configurations, often featuring interlocking designs that enable stable vertical stacking. They are extensively used for the efficient transportation and storage of smaller items, components in manufacturing processes, or goods within distribution centers. Their inherent durability, ease of cleaning, and stackability make them particularly well suited for closed-loop systems where they are used repeatedly. For more specialized applications, we have pouches. You can see them on the right-hand side, that are integrated in pouch sorter systems. These pouches are for internal use only, and they don't leave the system. Their primary application is for apparel and small products like pharmaceuticals.